model equals new counter. And I create model. Okay, so that explains what that's doing then.
Okay.
Before it was just like this, that, what?
What is on? And right. Well, just to go over, something that I think is related to app programming, but not necessarily the programming part. I was having dinner with somebody, and he brought up, there are certain types of applications. One is called Zello, Zello. It turns your phone into kind of more like a walkie-talkie. And I think it's an interesting concept, especially I have not really looked into its mechanism yet, but if it uses the Wi-Fi capability of a phone and turn it into a ad hoc network so that a phone can talk to another phone, basically turns the phone into a walkie-talkie. Okay, so you can press a button and then talk to it, and then the other people who subscribe to quote unquote your channel can listen to what you have to say in real time. That is actually quite useful, because I can remember going to camping trips where there's no Wi-Fi, there's no 4G or cell phone signals. So all the cell phones are quote unquote dead, because of that. Now, if your cell phone has Wi-Fi capabilities, and you can just set up an ad hoc network using your Wi-Fi capability, you can still have an app to turn your cell phone into a walkie-talkie. And that can still be useful. So I just thought, hey, that's not a bad idea. I mean, that's really kind of cool. So that's one app that I was that I just installed last night. Everybody already knows about WhatsApp, right? Facebook spent $19 billion to buy WhatsApp. Well, that's kind of interesting too by itself, because WhatsApp, how many people have WhatsApp already installed on your phone just because of all the buzz of the purchase? Nobody. Okay. Well, I have it installed because I had a trip to Hong Kong over the winter break, and everybody in Hong Kong uses WhatsApp for chatting. They don't use SMS chatting, which we typically use here, because the data plan in Hong Kong is actually very inexpensive compared to the voice plan or text plan. Okay, data is like almost free, but everything else was expensive, which is really interesting because SMS, what we usually use for texting purposes, actually uses a surplus capacity of the cellular network capability. In other words, the carriers don't really have to pay any additional resources to get the texting mechanism going. It's already there, and yet they charge a lot of money for texting. Okay, so it's almost like pure profit from the standpoint of the operators. So WhatsApp is coming in and taking a big chunk out of that money because whenever you have Wi-Fi access, it can be TextNet here, can be the school's network, which I heard is now fixed. It is actually operational to the point where you can use it for homework. Go ahead. Do you want to check it? But anywhere you have Wi-Fi access, you can do texting using WhatsApp without using an SMS plan. The only question is how quickly will people switch? Because even if you switch today, if all of your buddies do not switch, then it's still useless to you. Okay. But the thing is, if everybody starts to switch, the scale can tip very quickly. Okay. So I just thought that's really kind of interesting. How it never got popular here in the United States, and having Facebook to purchase that company will kind of change everything because now it has visibility. People did not know about WhatsApp, now they do. And it's going to change the way, I think it's going to change the way carriers operate in this country, because they can probably no longer depend on the texting charge as an income revenue, and they have to figure out something else.
Yeah, so AT&T, it's currently pushing people into this the family plan where it includes unlimited text as well. Where I'm assuming that they see it coming, where the usage of texting might be dropping. So.
Well, it's going to drop. It's going to be dropping for multiple reasons, not just one. One reason why it might be dropping, has to do with, well, WhatsApp is one, but the second thing is, a lot of people now have, Wi-Fi access, 24/7. Okay, they get it at school, they get it at work, they get it at home, they get it at Starbucks, they get it at multiple places. So there's no reason to pay for your texting. And how much do you pay for each text message? Is it like 10 cents if you don't have a good plan? It's go ahead.
The other thing is the carriers, the new carriers, or at least Metro PCS, who have that unlimited text. That pushed the Sprint, AT&T, and pretty soon Verizon as well, because it has to catch up, otherwise it's going to get dropped. So the competition has a lot to do with it.
Mm-hmm. Now AT&T is planning to buy. They were planning to buy T-Mobile before, but now they were planning to buy somebody else. There's a merger, between Sprint and somebody else? I cannot remember, who was buying whom, but it was another thing. And that can change the landscape, of all of these things. And you can see how an app, can actually help change the landscape, because it just makes, it just changes the economy of doing, something like communication with somebody else. When I was in Hong Kong, I hardly remember seeing anyone on the phone actually, talking on the phone. Most people are texting. They're just, using the phone as a terminal to text, because, you can do it in near real time, or you can do it, offline. Okay, I text you, you're in class, 2 hours later, you can return my text. But if I do a phone call, it is actually not as convenient. So it's all kind of interesting how, we are shifting our habit because of because of apps. All right. So what I'll do today is I'm going to use this as an example to illustrate, how to use the design pattern we talked about last week and apply it to a new example, that I'm just going to do in class today. Yep.
Did you start recording?
Yes, it is recording. And it doesn't hurt to double check. Yep, it's definitely recording, and the voice is getting recorded as well. So unless the hard drive crashes and I lose whatever I have here, then we should be good to go. Okay, so what we'll do today is to play rock, paper, scissors as a game. Okay, and I'm not going to play the extended version of rock, paper, scissors, Spock, lizard. Do you guys know about the extended version? Yeah. 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 So for those of you who are kind of curious of what I'm talking about, is rock, paper, scissors, lizard, Spock. Okay, I got it reversed.
The diagram.
Yeah, it even has a diagram. Rock crushes lizard, lizard poisons Spock, Spock smashes scissors, and it's basically an extended version from what's the name of that show? Big Bang Theory. There you go.
So all you need to do is choose paper or lizard, then you'll win every time.
Do they?
Because everyone was choosing Spock.
Oh. In that show, yes, in that show. Yep. Then you are using probability to help you, win the game. Okay, so in this case, we're just using the regular version of rock, paper, scissors. But the whole point is to illustrate, how do we get started with designing the app? Because you can certainly write this app without using the model view adapter architectural design pattern. In other words, you can just attach all the logic to a single class, which is our main activity, and you're done. Okay, you don't have to worry about a single thing. But what we'll do is we'll try to use this approach and see how we can separate the view from the model using the adapter in between. Okay. And once again, the whole point of doing this is, it may not be useful or even, it doesn't seem to make any sense for simple applications, but for larger applications, it starts to make sense because your team is not just a person anymore, and it's not just something that you do over a few hours. It is something that will take, at least, weeks to complete, and you have multiple, teams to deal with, right? So we'll go to the folder and get Eclipse started first. Yes, I could have written a script to get it all started, without having to change the folders, but changing folders is not all that much of work anyway. All right, and I have to change this back to just the regular user workspace because last time I did not start my persistence drive natively, so I had to change the path to find the project. All right, so we'll go ahead and start a new project. Could not find SDK folder. Fine. Tell you where it is. SDK folder. Is it happier now?
You just open one of them up.
Hmm?
It needs to reload, so just open one up.
Yep, it's happy. All right, so what we'll do is we'll go ahead and create, the app first. So we'll go ahead and say create Android application project, and I'm going to use my convention of using Los Rios edu and then ARC, this class, my last name, and then the name of the project. And of course, I typed this in the wrong place. Start here, and we'll just say this is rock, paper, scissors, RPS. Package name. I think we can just attach RPS here. Wonder why it was not automatically there. All right, so we'll go ahead and get it started. I'm going to switch to API 11 as the default now, just because it supports a lot more features compared to API level 8, I think, by default, or 9. And everything, I'll just take it, as the default, get started, and get finished. All right, so we have the default screen, which is the main activity class definition. Let me ask you guys, how would you start with your app? Do you start with this part, or do you start with somewhere else in your application? When you're writing an application, you have an idea, you think, okay, I think I know what I want my app to look like. So how do you get started with your app?
Omelet.
Omelet, okay. And you use Omelet to create the diagrams as a documentation tool.
Yeah.
So Omelet is one of the many ways you can do documentation. You can even write it down, right? I mean, you can say, okay, here's my use case diagram, but it's not an actual diagram. And you can say, okay, I have these actors representing types of users who will be interacting with your application, and they can use your use cases like these and so on. So you can still use your regular text to describe what your app is about, who's going to use it and for what purpose are they using your app. But it's not as easy or clear, as with a use case diagram. Yep.
Personally, if I'm just doing it for myself, I just do like a rough process, just to get certain functionality in there without using a interface.
Formal diagram?
Yeah.
Okay. If you're doing it as a relatively small project, it's okay. But if you involve a team of people, to write an app, sometimes it is helpful to have a documentation, because then you can share that document with the rest of the team, and hopefully they know how to read the diagram, because they all have training in reading the UML diagrams. So it depends a lot on the scale of the project, and this is one thing about apps is you can start with something very simple, and even make money out of it. Okay, Flapping Bird being one of those. And they're, sorry?
Just have to generate enough money.
Yep, exactly. Then it will go viral, right? I mean, and that's the whole point. But you can also write, fairly complicated apps that has, only one small portion running on your phone, and then you have a heavy-duty, backend that is running in the cloud. Okay, there are applications like that as well. I'll give you one example. The Wells Fargo bank application is like that. Okay, there's one little piece that is running on your phone, but the actual backend, is actually running on a server, somewhere in the cloud. So, so that's basically, you can have really complicated apps, you can have simple apps, and you can have everything in between. Yep.
You're talking about using the phone as a dumb terminal, basically.
I think it has a certain level of intelligence, but not. Definitely, the business logic is not on the phone itself.
Yeah, it's just a client.
Yeah, the phone probably has the logic to do authentication, has simple logic maybe to check amounts in your account and stuff like that. Certainly has the logic to format the display. Yep.
Also take pictures of checks.
Yep, that they can do, except on my phone. They broke it, so it no longer hooks up to the camera correctly on my phone, and I can still use every other app that uses my camera except for the Wells Fargo Bank application.
Isn't your phone like 6 years old though?
No, it's a Blaze. I mean, it's at the most 3 years old.
What's the version of Android on it?
I have 4.4.2.
He has Cyanogen mod on his.
I have Cyanogen mod 11. And typically, going to a newer version of, the OS, should not cause, backward compatibility issues. We kind of talked about it in this class too, because it has a emulation layer or pretend layer. So if you try to run older apps on a newer phone, it will still run, it just doesn't look right. It just looks kind of dated and ancient. Right, so getting back to this example, rock, paper, scissors. So what we'll do is we'll go through the notes here, it's a little bit, and it's really just a guideline or just a reminder to myself of what we need to do. So the first thing you might want to consider doing is to use a use case diagram or some other means to document what the application is supposed to do, or why would anyone try to install your application? What are they going to use your application for? You don't have to describe the details. So for a banking application, you don't have to say authentication, because authentication is not why they install your application. Would anyone install an online banking app just to do the authentication part? Well, if not, then it does not belong in the use case diagram. So what is the purpose? Why would I install the Wells Fargo Bank application? Well, I might want to deposit checks online. Okay, well, make that a use case. I might want to pay my bills online. Okay, make that a use case. But authentication is not one of those. Changing my password, borderline. Okay, probably does not belong there either. All right. So now that we have the use case diagram, in this particular case, it's simple. It's the one single use case that I can only think of is to play rock, paper, scissors. Okay. A use case, if the label of a use case is not starting with a verb, or the phrase itself is not describing an action, something is not right. Okay, and a use case should always be an action. Why would somebody install your application? Because they can do something. Okay, so that's why it should always be an action. Now, when you have a use case, you also need to describe, who is going to use it. Okay, who is going to interact with this particular system. In this case, it's also quite simple. Somebody who wants to play rock, paper, scissors. Okay, so I'm just going to call that actor rock, paper, scissors player. But we have to remember that this is not describing a single user. It's describing an entire class of users, a classification of users. And it's not only limited to a human user. It can also be another system, for different types of use case diagrams. Now, once we have the use case diagram done, there are some potentially intermediate steps. But in this case, I'm just going to jump to the state machine diagram right away. And in this case, the state machine diagram has to keep track of the game itself. So it's up to you. It's kind of up to you to decide how you want to set up the game. And I'm going to construct the picture right now, so that you can actually see how I do this. So I'm going to run the startup omelet and draw a picture representing that state diagram. In omelet, you can use this menu here to go to state machine. So this way, it only shows you the kind of construct that makes sense in a state diagram, and will hide everything else. If you go back to the other one, which is the default, you can do a lot of things. But many of these do not belong in a state diagram. So I'm going to switch it back to just state machine, and we'll always start with a start state and an end state. Now the end state is the one that looks like an eyeball, with an eye in between, inside the other circle. And now we have to think about, okay, when we are playing the game rock, paper, scissors, what kind of state am I going to track in a game like that? In other words, if I'm just playing the game with somebody else, a third person comes in, and what can that person inquire about the game itself? Okay, so you can say, well, we just use exactly the same sign 6 consecutive times, and we are still there's no winner or loser. Okay, you can say, oh, I just lost, okay, or I lost so many times. So that's kind of a description of the game itself. Or we are done, okay, I lost 7 times and I'm giving up, okay. Or we're just starting, okay, we haven't even played yet. Those are the descriptions of the game, and we're trying to capture those descriptions using a state diagram. Are there any questions about what a state diagram is about? Or what is a state that we are trying to capture in a state diagram? In your homework assignment, the states correspond to state of water molecules. Okay, so it can be steam, can be water, can be ice. Okay, it is once again a description. Each one is a description of the thing that you're trying to model, or the thing that you're trying to describe. In this case, I'm trying to describe a game of rock, paper, scissors. The initial state does not require any documentation, because it is what is starting the entire thing. In between, we have at least 3 states in this case. So I'm just going to make 3 states here. The first state is just saying that we don't have any winners yet. Okay, no winner. The second state, I'll describe it as the end user wins, which is one possible outcome of rock, paper, scissors. And then the last one is the app wins. All right. So these are 3 things that are descriptive of a particular rock, paper, scissors game. If you want to keep track of a counter of how many times each party has won, that's okay too. But we're not going to use states for that purpose, because if you try to use states to also represent the number of times that the computer or the app has won, and the number of times that the end user has won, then you end up with a lot of states that are not necessary. In other words, for certain things, we can use a counter that is invisible from the state diagram to keep track of all that information. But in this case, it's a very simple one. We just want to track who won the previous game. So there's no counter involved in this case. Now we have to think about the transitions. Each transition is representing a way for a particular state to transition to another state. So if I make a transition here, the first one is going to the no winner state from the initial state. In other words, at the very beginning, it will take a transition that does not require external interaction and go straight to the state of no winner, because the game has just started. From the no winner state, we can have transitions going to the app wins in one case, and we can also have transitions going to the other one, the end user wins. In other words, in this case, these transitions are triggered by the end user pressing a button. Okay, do you want your rock, paper, or scissors? And then the system will choose, will make its own choice, and then you have to determine, are we going back to itself, or are we moving on to one of these states? It is also possible to go back to the no winner state if the end user and the app choose the same sign to begin with, which is entirely possible. So I can move this one all the way to here, and then we can have a transition going back to itself. We'll go ahead and move this over here. You can actually, change it. You can actually add additional vertices to kind of draw, whatever you need to draw. So in this case, I can add a new vertex so that I can make this transition point back to itself. All you have to do is to just drag a point so it becomes crooked. But that point becomes, its own draggable point. So I can go back to the no winner state if the choice of the app and the choice of the end user turn out to be the same. Are we still doing okay so far with this state diagram? Okay. Now, if you want to make this game so that the end user can choose to play again, from these two other transitions, you can definitely do that by attaching additional transitions. Oops. Okay. Now we have a problem because they were both at the same point. Readjust this one so that it's not crooked anymore. So now you can say the user wins this game, but the user can also press a button and say, play again, I want to play again. Okay? And then the system will go back to the no winner state. And every time it goes back to the no winner state, maybe it will trigger something to happen too. Because every state change can potentially trigger a listener to say, oh, okay, the state machine diagram has changed its state. I better do something about it. Okay, but we'll talk about that later. Right now, we are just capturing the logic of the model of the state machine diagram. And then we'll have another one. I can just move the whole thing first, so this way it's easier. And have this guy come back to there. Okay, everything is attached. All right. So the question now is, how do we get to the final state? How do we say, okay, we are done. I don't want to play this game anymore. What transition, or from what state can I make that transition to the final state? Well, the answer is you can program it either way, okay? But you have to describe it properly in the state diagram. If you say, okay, if the user wins, you present the screen and you give the user a choice to play again or to exit the game, then you need that transition from the end user wins state to the final state. On the other hand, if you want to program it so that the only way to get back is from the no winner state, okay, we're playing a new game, so in addition to rock, paper, scissors, you also have another button or another way to say, okay, we're done, okay, we don't want to play this game anymore, maybe using just the back button. That will make it so that you can only go from the no winner state to the final state. Okay, but whichever way you want to write it, you have to document it here properly, so that way, when you're actually writing the code, you can refer to the state diagram and say, did I write, did I put in the logic to represent this particular transition? Are there any questions at this point about this entire, are there any questions about how to create your state diagram and what you have to kind of think about when you create your state diagram? No questions? So what I'll do is I'm going to add that one link here, but I'm going to go from every state to the final state here. Because what I'm going to do is I will just be a little bit lazy and say if they press the back button, that would cause a transition back to the initial state. And I can do it like this. And we have one last transition to go from the end user wins to that state. Okay, I can always have it one here first, and then make the arrow like that. All right. So now we have, from each state, we have a way to get to the final state. Now it's time to label, all these transitions. This is where Omelette is not really good at, because, Omelette can only put the text at a certain point. You can actually drag the text, once you have the additional breaking point, but it doesn't give you really, all the flexibility either. All right, so let's look at this transition first. This is the initial transition. It goes from the initial state to the first state. Typically, what we do is we do not require a trigger. In other words, there's no interaction required on the user's part to go from the initial state to the first state. Okay. In other words, this is really just for initialization purposes. If there's nothing that the user has to do to get here, I'm still going to use a slash here to indicate there's no trigger required. Okay. Because the first portion of a transition is to specify the trigger as well as a guard condition. And then the second part after the slash specifies the action involved. When this transition happens, what am I going to do inside the state machine? So in this case, I can just say initialize, or if you want to be more specific, you can also use the open and close parentheses. So this way you're indicating it does not require any parameters. And let's take a look at this transition here. Okay, there are several options to document, this transition from the no winner state to the end user's wins. You can make it very spelled out. In other words, the end user specifies scissors, and the system chooses paper. Okay, that's one scenario where this can happen. In other words, I can make this very detail oriented. I can say user choice equals scissors, and I'm using uppercase, all uppercase here to indicate this is an integer. It's just the symbolic name of an integer. But that alone doesn't mean the user is winning. You also have to say app choice, the app chose paper. Okay? That becomes one single condition for the end user to win. There are two other ways, right? Okay, because the end user can choose rock, and the app chose app. Let's see, rock beats scissors, right? And you can spell it out like that. But you can also choose to do it in a slightly different way. You basically defer this decision to another subroutine. Okay, so you can say, instead of this, you can say, okay, first of all, you need a transition. You need something that happens outside of the state machine that triggers this particular transition. In other words, the user made a choice. Okay, the user clicked a button, made a choice. Now it's time to evaluate whether that choice is going to cause this transition to happen. So one way to describe it is to basically say user chooses. Okay, and that's the trigger. The user actually picks something. Okay, there's an interaction. And then you can specify in parentheses what is the guard condition. As I said a little bit earlier, the guard condition can be spelled out using 3 conjunctions or 3 AND expressions. They have to be joined by or you can use another subroutine to make that decision. Okay, so the subroutine here, you can say does user win? That becomes a subroutine that you call to become the guard condition. So if the subroutine returns non-zero, that means the user actually won this particular game. If the otherwise, it simply means the user did not win the game, because you have 3 possible states. You can have the user winning, you can have the user losing, or you can have a draw. Is that okay so far? Okay. It is also up to you, kind of, to decide, how you want to make this subroutine work. You can make this subroutine work by saying it can return 3 possible values. It can return a constant value of the user winning. You can have it to return another constant value of the user losing, and have a third value to indicate a draw. It's okay to do it that way, but you have to define the constants, to make that work. The alternative is to do it in a way of having subroutines that only return true or false. Did the user win? No. Well, but in that case, you have to ask 2 additional questions. Did the user lose? No. Well, then the third one is implied, which means it's a draw. Okay, so you can also implement it that way. Now we have to specify, if the user just made a choice and the user won, what is the system going to do? What is the system going to do that will change its internal state? Well, it's up to you to decide. You can say increment the win counter if you want to keep track of how many times the user has won this game. You can do some additional stuff, but assuming you don't have any additional stuff to do, you can just put a slash here and say that, well, I don't have any really specific action to perform at this time. And then that becomes the end of this transition. To go back in this, to document this particular transition is a little bit different. And with this particular transition, we are already saying that the user has won already. The question is, does the user want to play another game? Okay. In other words, in this case, it's fairly easy to document. You just basically say, okay, what is the trigger? The trigger is user, play again. The user chooses to play again. That's the trigger. In other words, this is describing an event or trigger that can only be coming from outside of this particular state machine. It is not from within the state machine. There's no guard condition to specify. In other words, if the end user clicks a button and say, I want to play again, we are going back to the other state without any further action or condition. So we can just put a slash here to basically say, okay, there's no guard condition, and also at the same time, there's no specific action that changes anything internal to the state machine. And you can see why I said this is not. You can. Let's see if I can move. Oh, I see. It's not attached yet. So let me make them attached first, and then we can see. I can move it away like this, but it just kind of looks ugly. But at least now we can see the text of both transitions and not combining those into one.
Quick question on the previous transition.
Right.
It seems like the user chooses function. Method or whatever you call there, will you invoke that even when you transition to app points?
The trigger, the name of the trigger is user chooses. The user pick
But it's a transition to the end user wins, right? So it seems like it should be user win is the trigger.
No, but the user win. Whether the user is winning or not is a condition. It is a guard condition. We have 2 constructs here. One construct is a trigger, which is basically saying, okay, something external to this particular machine happened.
Right.
Okay, and in this case, what happened was the user made a choice. Okay, I click a button. Okay, that's the external event. That is a trigger.
Yeah.
Now, on top of the trigger, you can associate with each transition what we call a guard condition. A guard condition is a condition, which means it is returning either true or false. So that means even in the presence of the trigger, I click a button, but if the condition of the user winning is not true, this transition is still not going to happen.
So user chooses as a trigger, does user win is the guard condition?
That is correct. I use parentheses after the trigger to store the condition, the guard condition. And as a result, I can also document this one kind of similarly, except it is user chooses, but does user lose becomes the guard condition, because the user can win, the user can lose. That also means that in this particular case, it is the user chooses, but it is not does user win, and it is not the user lose. So the user did not win nor lose, and it's a draw, and that's why we go back to the no winner state. Are we still doing okay so far with this?
So in that, the trigger is still user chooses, but
yeah.
the guard condition would be no winner or something like that.
Correct. So if I were to document this entirely, it would become user chooses. It is using the same trigger. The guard condition in this case is not does user does not win basically.
Well, that
and
one.
Winner does not lose. That becomes my entire trigger, because the first part specifies what external thing has to happen in order for this transitions to get a chance of being evaluated. But I also specify that it has a guard condition. The guard condition is basically saying the user cannot be winning, cannot be losing at the same time in order for this transition to occur. And then I use a slash here to indicate there's no action afterwards. In other words, I'm using the slash as a separator between the trigger slash guard condition part as opposed to the action part. The action part specifies something that you can do to the internal part of the state machine. You can say, okay, increment a counter, or something that is not visible externally, but it does impact the state machine itself. So are there any questions at this point? No questions? Okay. I'm not going to document this one, because it's very similar to the other one, except the guard condition is the user loses this particular game. But I do want to document one more transition, which is this one here. In other words, how do I document this transition going to the final state? Now there are several ways that you can look at this, but in this case, I'm going to say the back button pressed. Okay, so back button pressed is the trigger. Okay, you press the back button on your mobile application, and it will trigger the whole thing to get to the final state, which basically says, I'm ready to close this game. And put a slash here to basically say, do I have any action to perform in this case? There's no guard condition. In other words, I'm not saying, okay, if you press the back button, only sometimes I will go to the final state. Okay, this means I'm always going to the final state and saying, okay, the game is done. Okay, this model will now cease to exist. Yep.
So no user confirmation?
No user confirmation. Do you want to? Are you sure you want to end this game?
And I accidentally press that button.
But that's a good question. How would you document that one extra question? Do you really want to exit this game? How would you document it in the state diagram?
Play again, yes or no?
Okay, but what do you need to do? Modify what do you need to do to modify the state diagram to reflect that you have one extra step involved, so that the user has a chance to say, "Oh, I didn't really mean to back out of the game." You need one extra state.
Yeah.
Yep, one extra state to do it. You need one extra state, because out of that one extra state, there are two transitions. One will get you all the way back to no winner, and the other one will get to the final state. So to implement what you said, you would need to have an extra state to represent the user not sure about exiting. Okay, because that's what the state is actually representing.
When it returned back to the exact location it was called from?
You already won or already lost. You're just going back to start a new game.
Yes, but if you press back, may not want to start the game over again. You may want to return to the exact screen you were at.
Okay, I see what you mean. That will involve, a new type of state that we haven't heard about. It's called the history state. Remember, you can actually see it over here. There's a state here that has an H symbol in it. Mm-hmm. That is actually an interesting one because it's similar to the ability for a browser to go back to a previous state. The H state or the history state, there are two variants of a history state, but the purpose of the history state is what you actually just said, is it can save the state of the state machine itself and be able to, quote unquote, backtrack to an earlier state. But in this case, I'm not going to make it complicated like that. We'll just kind of say that, we'll just do it this way without a way to kind of go back to a previous state and say, okay, I didn't really mean to exit the game. Okay.
Wait, the history state is sort of save the current state in a persistent storage.
Right. It basically adds persistence to the state machine. So later on, if you choose, you can resume the state machine from its history.
Okay.
Right.
So like for example, if I were the app ended at the user wins, and I exit and store the history when I come back.
Once you exit, you lose your history. So what it does is it allows you to suspend the state machine and be able to resume the state machine. In the history state, if you look at all the state diagrams involving the history state, it's treated differently from a regular state. There's no outgoing transition from the history state because it is implied that from that state you can go to any particular state to resume its previous state. But when you get to the final state, you are actually done. At that point, the history itself is erased. So are we doing okay so far with this state diagram? It is incomplete. I just want to show you enough detail so they can see, what it is useful for, and what each state is describing. Why, if you have the additional state of, confirm before you exit. The description of the state is the app is not sure whether the user really wants to exit or not. Or to the same effect, because that's what that state is really representing. Is I'm not quite sure that you want to exit at this point, or need confirmation to exit.
I'm assuming in Android there's a way to save, like for example, you're playing a game.
Nope, there's no built-in method to do it. There's no built-in method to save the state of your application. You will need to implement your own logic to save the state of your application. It is entirely dependent on what kind of application you're dealing with. If you're dealing with, let's say, WebKit, which is the default browser, it certainly can store the URLs that are open at the time when you, let's say, shut down your entire Android operating system. And that's what it does too. If you have the experience of closing or power down your Android device, and you already have, like, let's say 6 tabs open in your browser, when you cycle power and start up the machine and you start up your WebKit again, it will bring those tabs back up. It remembers that you had those 6 tabs already open when it shuts down.
In that case, what is a saved instant state? That saves your state when you rotate your when you change the orientation. It recreates the screen as a new screen, then takes that and reloads the values.
Okay, but that only applies to the state of each individual control element. But the internal state, because the Android framework is not aware of the underlying representation. It knows everything about the activity, the buttons, your text view, everything. Okay, the coordinates of all of that stuff, it knows already. If you choose a particular layout, anything other than an absolute layout, the system framework is responsible to kind of flow all the things, so that it looks okay. So it can save all of that state. When you rotate it back, it knows how to resume all that stuff. But as far as what a button is really representing in your actual application, it has no idea what it is actually representing. And that is the portion that it cannot save automatically because it doesn't know which portion it needs to save and which portion it does not need to save. Since we are on this topic, I'll just kind of bring up one thing that you might find useful, for that particular topic. It has to do with the concept of serialization of Java objects. There we go. Okay. Serialization is basically saying, okay, how do I start with a particular object and be able to spill out text, essentially, to represent that object itself. And there's a way to do it. Java provides a mechanism called serialization, where an object, okay, let me just kind of bump up the font size first. It's a little bit too much. Okay, I think that's good. Java provides a mechanism called object serialization, where an object can be represented as a sequence of bytes that include the object's data as well as information about the object's type and types of data stored in the object. So this is basically with the intention of being able to recreate that object later on when you retrieve those bytes as a stream from another source. And this gives you, whether this is in text or not is irrelevant, okay? Because if it's in text, it simply means it's easier for you to view or to visualize what it is representing. But there's always a way to convert it back into a text representation where you can see it. After a serialized object has been written to a file, it can be read from the file and deserialize or reconstruct the object. That is, the type information and bytes that represent the object and its data can be used to recreate the object in memory. So this is a really useful mechanism when you need to say, okay, I need to suspend or to store the state of this particular app at this point, and I'm going to power down my entire Android device. So you need a way to store the state of your entire app, okay, in a way so that it is in persistent memory, which is your flash drive. And then later on, when you restore the app, it will bring everything back up to exactly the same point where you left off. And this would be a mechanism that you may find useful for that purpose.
It seems like you could pass objects between applications too.
That becomes a little bit more tricky. It depends on, okay, the tricky part of this whole mechanism is what if your object refers to other objects? Okay?
Yeah.
So if your object or the object that you are serializing is referring to another object, then the mechanism would actually traverse every single one of those references and say, oh, I see that you're referring to this other object. Let me serialize and put the stream of that object into the object too, because otherwise this would not be a very useful mechanism. If it's a one level kind of thing, then it's not going to be useful. So the difficulty now is if you're trying to restore this object into a different application or to a different machine, then certain things that you're restoring may conflict with whatever is there already. Okay. So that's why it's useful only if you already know that whatever you're trying to serialize is not linking back to something else that will cause problems later on when you deserialize or reconstruct the objects. And then describes, most impressive is the entire process is JVM independent, which means an object can be serialized on one platform and deserialized on an entirely different platform. And once again, when you deserialize, you have to be aware of its side effects. Okay, what else is it going to reconstruct, when it deserializes? Are there any questions about this mechanism? Okay, I will leave it to you to kind of read about this because it's a very useful mechanism. For those of you who took cisp363, you probably remember that we kind of looked into this whole thing, and I wrote a subroutine to serialize a list, which is the best we could come to representing the internal data structure of an application in App Inventor, because App Inventor does not have the entire interface to deal with the Java. Getting back to our application here, and getting back to the picture because we were looking at the picture. Okay, so now we are ready to kind of proceed with writing some code. I'm not even done with the picture yet, but because given the amount of time we have in class, I cannot just say, oh, let's go ahead and finish the entire state diagram before we continue with our writing of the application. So getting back to Eclipse, I now need to create a few things. Okay, if you look at this part here, it kind of gives you an idea of what the model needs. The question now is which part of this is needed from the outside of the model. In other words, if I'm something, if I'm a class outside of the model, and I need to tell the model, hey, you know what, somebody just made a choice, in rock, paper, scissors, do something about it. Okay, if I'm external to the model, to the state diagram, what interface do I need in order to tell the state machine to do something? That's the question. Okay, what do you think?
User wins and app wins?
No, not really. Okay, whether the user is winning or not is business-related logic, and only the model needs to know that. In other words, the subroutines, does user win and does user lose, is not something that has to be exposed to the rest of the world. It is specific to this particular game. What has to be exposed to the external world would be the user interactions, the triggers. And the triggers in this case would be user chooses, okay, is one trigger. Play again is a trigger. The back button being pressed is a trigger. In other words, those are the things that can happen, that can occur outside of the state machine, that can cause the state machine to do something. It's basically kicking the state machine once and say, hey, you need to do something about this. And that is important to the external world. So when I switch back to Eclipse, I would go to the source here, and the first thing I'm going to do, actually that's the wrong app, isn't it? Okay, we have rock, paper, scissors, and this is where we are. And the first thing I'm going to do is to create a new interface. I'm not going to create a new class. I'm going to create a new interface first to basically say, okay, what does the model class needs to do in order to qualify as a model class? Okay. Let me go ahead and get started with this one first, and then we'll go back and talk about, what is the difference between an interface as opposed to a class. So here we're creating a new Java interface. We will keep everything by default, and instead, we'll just say, this is started with an I, to indicate it is an interface. It's an interface of the rock, paper, scissors model. And I will make this public. Modify is public, and it does not extend any other interfaces. It is by itself. So we'll go ahead and create a class which is stored in its own file. Okay, this is its own file. The file is I, which is interface rock, paper, scissors model.java. Now we have to define all the methods that an actual model class needs to provide. Okay. There's a difference between a class as opposed to an interface. You can define that interface using the actual language construct, such as With an interface, you cannot define the body of a method. You can only define a stub and say that, okay, there's a method like this. It has this return type, and the parameters need to be like this. But you cannot say what is the actual method. Okay, what does it do? You cannot specify that as a part of the interface. That's a language description of what an interface is. But when you look at the actual meaning of an interface, it is describing what something can do, but not how to do it. Okay, let me just say that one more time. When you look at an interface, every definition, every method definition of an interface specifies what can be done, but not how it is done. When you look into a class, with the exception of an abstract class, which intentionally you do not specify how to do something, when you look at a class, it is about how do you get something done. Are we doing okay so far with the differentiation of what can be done as opposed to how it is done? The nice thing about the interface is if you go through an interface as a parameter or as a reference to something else, you are now not placing any inheritance restriction to whatever is going to be passed as a parameter or whatever you're trying to refer to. So you're relaxing, a very important part of Java programming, because when you have class inheritance, one class can only have up to one superclass. That's it. Okay. If you use up that one superclass because you want to specify it as a parameter type, then that class cannot inherit from anything else after that. On the other hand, if you use an interface, then you're okay, because a particular class can implement any number of interfaces, which is great, because now you're not placing any restriction on the class itself. It is just it can still do any type of inheritance that you feel necessary for the class to inherit from. Okay, so right here we're going to go back to the picture here, and then we'll say, okay, what does a model need to be able to do, or what are the triggers from the external point of view, and say, hey, rock paper scissors model, something just happened, you need to do some processing. What are the entry point of triggering the logic of this particular model? Every single trigger is a method by itself. So in this case, we have a public method of I just forgot about the user chooses. Okay, I'm just going to call it user chooses, and at this point we can just leave it as a function, as a method like this with no parameters. But you will see later on that we can also use parameters to indicate the choice, because the other way you can do this is you can say user chooses rock, user chooses paper, and user chooses rock, paper, scissors. Okay, but that would be kind of really redundant, because now you have three methods in order to represent the three possible actions that the user can take. But if I use this method, I can use a parameter to indicate the actual choice, and that becomes a little bit easier to deal with. Or at least I can clean up the interface a little bit better this way. The other one is to start. Okay, so public void start or initialize. Okay. Because from the external perspective, you can say, okay, I want this model object to reset itself or initialize, so it starts with the beginning point of the entire object. And then we have play again. Okay, once again, this is something from the external part, so we have to represent it here. Public void. I can call here play again. All right, and then one more is the back button pressed. Now the back button pressed is actually not a very good name, because you can probably rename it to the user is requesting to exit the game. Okay, but I'm just going to keep it here using the same name. Back button pressed. Okay. All right. Let's see what else we have to specify as a part of the interface. What about does user win and does user lose? I mean, those obviously are seem like methods that we are calling, but do they belong in the interface? They do not belong to the interface because it is specific to the logic of the game. The interface, should not need to care about that. Okay, if you're external to the state machine, you should not need to have to worry about it. You just have to say, okay, something just happens. Do some processing. I don't care the logic about the processing. I just need to tell you that something just happened. It requires your attention. There are a few things that we also need from the model interface type definition. One has to do with a model cannot be just by itself receiving all these triggers, but change its internal states and go through the entire life cycle, but without reflecting the changes to somebody else. In other words, when we make a transition, maybe somebody needs to know about it. Okay? In other words, let me switch back to the picture here. When we make a transition from no winner to the end user wins, maybe someone needs to know about it and do something about that transition. The state machine obviously is going to keep track of its own internal state and say, okay, I know that the end user wins this round. But who else is going to know about it? Nobody. Okay? Because there's no way for a model to say, okay, update the screen or send this message to the server. We want to keep track of all the win-lose count and so on and so forth. The model doesn't know how to do it. Okay? Its only job is to understand the rules of how the game is played, and that's it. So that's why a model needs to register with a listener adapter to basically say, okay, I need an adapter, a broker, okay, so that when I have an internal state change, I can let the broker know, okay, I just changed my internal state, and the broker in return is responsible to tell everybody who is interested in the state change of this state machine and say, you know what, the end user just won another round. And then each listener can decide what to do about it. Do you want to reflect it on the screen, pop up a dialog box, or do you want to send a request to a server to increment a counter, assuming this is a game that can be played over the network? Well, the model doesn't care, right? The model just wants to say, okay, I have determined that for this round the user has won. Go tell somebody about it. Okay? Tell the broker and say, tell whoever needs to know about it. I don't really know what to do about it. I just know that I have a state change. Is that working out okay? All right. Kind of like, I think last time we used this analogy too, when you are, let's say you're in the market of buying a house, okay? So you are, quote unquote, a model, okay? And you have a lot of internal states. In other words, how much money do you have access to? Do you need like a ramp for wheelchair? How big of a driveway? Those are all internal to you as a potential house buyer. So let's just say that initially when you were on the market to buy a house, you can only borrow this much money for the down payment, and your paycheck can support a mortgage up to a certain point. So you tell your broker and say, okay, this is all I can afford, and then the broker will go out and try to look for houses for you. That's the job of the broker, right? Let's say at some point you won the lottery. Okay, now when you win the lottery, it is a state change. Okay, it is an internal state change because now you have more funding available to purchase the house. Okay, maybe you can pay off a fairly expensive house all in one shot. But what are you going to do? Well, you have to tell your broker first, right? Then your broker can tell all the other listening parties and say, okay, you know what, my client now can afford a house up to this price point, not just the price point before. And then the listeners can now respond to that and go, oh, okay, now we can have these houses also open up as possibilities. So the bottom line is, it is not documented in the state machine diagram, but when you specify the interface, a model also needs a method to register with a listener or view adapter because that's the broker. You have to be able to sign up a broker with the model object itself. So in this case, we'll say set listener adapter. And once again, I choose to have no parameters at this point. We'll come back and specify the parameters later on. But what we are trying to do at this point is to identify what a model needs to be able to do in order to get this job done. Are we still doing okay so far with this? Okay, I'm just trying to define the skeleton of the methods of a model. This is not the only type of methods, but these are the methods that are usable or useful to the external world. All right. So now that the interface of a model is kind of done, we can kind of look into the details of how to implement this particular model. So what we'll do is we'll create another file, and this time we'll create an actual class representing a rock, paper, scissors model. So we'll call this RPS model, and the RPS part is kind of redundant because everything is rock, paper, scissors. So you don't really need to use that if you don't want to. Okay, but this time it is a class, and we'll keep everything as a default and finish this. Yep.
Can you please go back to the IRPS model?
Sure.
Does it play again the same as initialize?
Not necessarily. Not necessarily, because these are incoming requests. Play again is a user-triggered action, but initialize is not user-triggered. It's just the null transition from the initial state to the first state. It has to go through that. Now, having two methods gives you the option of not doing exactly the same thing depending on how you get to the no winner state. Because if you go through initialize, it is possible, because this is the first time you go from the initial state to the first state, maybe there's some extra thing that you have to do, like resetting the win-lose counter thing. Yep, go ahead.
I was about to say that. Same thing. You initialize and you lose your score and stuff like that.
Right, so there may be things that you want to do with one but not the other one. So when we go through the class definition, from time to time we have to go back to the interface to refine its interface, to refine the method definitions. Okay, so now we are in the RPS model class, and this class, for one thing, we have to make it implement the interface that we just talked about. IRPS model is the interface that we are talking about. And let's see if it's smart enough to do that. Okay.
Is it implements or implement?
Implements. Implements.
Yeah.
But let's see if it's smart enough to do add unimplemented methods. Oh, that is pretty smart.
To implement the methods that aren't there.
Nope, you couldn't make the association.
You clicked once, I think you may need to double click.
Let's implement the inherited abstract method, play again. So it knows about it. There we go. Cool. And there's no need to import because they're all in the same package. So even though they're in different files, but because they're in the same package, there's no need to import all the other names all over again, which is kind of handy. I mean, it's one extra import statement is not going to kill me by typing it, but still, it does make sense that if they're in the same package, that we don't need to mention import again, because importing is only done or required across packages. All right. So now we have to kind of look into each stub and say, well, but what are we going to do with each stub? the first thing we have to do is to say, well, internal to this class, we need a private member, which is going to implement, which is going to be of the interface type to the broker. Okay, the broker, I just call it, a listener adapter. And the name of the private member is just listener adapter. Now, obviously, this is going to be a problem because I have not defined the interface of listener adapter. So now I'm going to go back to Eclipse just to make it happy and say, well, let's go ahead and define it now. Go create the new interface, and we'll just call that, the interface of listener adapter. Click finish. Save everything. And that makes the, is that the right one? Yep. Double click, there we go. So it does make it happy, even though it has a warning and say, it's not used. We'll use it later. Okay. All right. And you can see that, I cannot, just work with one file and then just go in one direction because, as I add more private members to this class, I'm going to define new types, and then I have to create the stubs of the new types, and then later on, specify the content of the new types. Let's take care of this first. Listener adapter is easy to set up because all we need to do is to use this particular method and say it requires one parameter, which is an interface of a listener adapter, and we'll call that LA as the name of the parameter. And then we'll set our private member to the parameter in this case, which is listener adapter equals to LA. And obviously it has a problem with it because the parameter is missing from the class, from the interface definition itself. So it has two quick fixes. Neither is what I want. Because the two quick fixes, one is to create a new method in the interface that was defined earlier that will require that one extra parameter. That's not what I want to do, okay, because I want to replace it, right? The second option is to remove the add override annotation, which means, oh, this is not overriding the interface method. It is, internal to the class, it has nothing to do with the interface. That's not what I want to do either. So the third option, which is what I really want, that is not implemented here, is to go back to the interface of the model and change this so that it includes that interface. So I would have to go back here and add listener adapter as an interface. Yep.
Can you also add it, then remove the unused one?
Yeah, you can do it that way too. You can add a new one and then remove the one that you do not want anymore. But I just do not like to run that chance of forgetting to remove the one that I did not want. But you can certainly do it that way. I mean, it's a kind of like a workflow thing. It's kind of individual. All right. So I just took care of this really basic one. If I want to keep track of any type of counter, like the win-lose counter that we were talking about earlier, I will have to define members also for that purpose. So for the purpose of this discussion, let's say that we do want to keep track of that counter. So in that case, I will need an integer that is private, and private is the default classification. But I wouldn't mind typing it again just to emphasize this is something that is only internal to this class, not even subclasses. And yep, this is the right place. Okay, so we have a counter called user win counter, and another one user lose counter. And if you really want to, you can also keep track of the number of games that have been played up to this point, because if you just add up the win counter and the lose counter, that does not equal to the actual number of games that have been played, because what about those cases where you have a draw? Now, obviously, if you add up those three, you get a total number again. So it's up to you to decide, do you want to keep track of the total, the win counter, and the lose counter, or do you want to keep track of the win counter, lose counter, and the draw counter, because they are equivalent.
For the win ratio.
Well, the win ratio can be computed from the win, lose, and the total.
Yeah.
Yep. But I would prefer to keep everything as integers unless I have a need to go from integer to a float.
I was just saying in general, that's for a user to see.
Oh, to lose the to indicate the ratio. But to compute the ratio, it would be more convenient to have a total count, game counter. So we have another private here, and game counter. Basically, just how many games have been played up to this point. Now, with these counters already here, you can do the initialization here. In other words, when the object is created, you can say, oh, this is automatically initialized to 0. But personally, I think it is better to have a method to deal with it. You can do it in the constructor. You can also do it in initialize. In other words, everything that has to be reset when you start a new game, it is better to put it inside initialize. And then you can call initialize from inside the constructor, okay, if you want to. So I would put it here, and I'll explain why it is a better place to put it here instead of the constructor itself. Okay, so now we'll go back and say, okay, why do we not put it inside the constructor? Because most of the time you have a constructor to specify what needs to be done when an object of this class is first created. In other words, I will need a constructor to do this, and we need to mark this as public because the constructor has to be public. Destructor in C++ cannot be public.
Say that again?
A destructor in C++ cannot be public. Why? It makes sense, right? But why does it make sense?
Because you don't want other things arbitrarily calling the code that's supposed to be your object.
Because it has to be implicit, right? The destruction operation has to be implicit and not be able to be triggered manually. Now, if there's any action you want it to be able to trigger manually, but it's not always associated with the destructor, make it a separate member function, right? Make it a separate method. Then you can always call the other method manually. Which is also the point here, is if I really want to do some initialization here, I can just inside the method, the constructor method, I can then I can just call initialize. I can always do it this way. But this gives me the option of calling initialize without having the object constructed at the same time. I'm just basically saying, okay, here's a way to reset the entire game anytime I want to. Initialize is doing that. But I can also say, you know what? When I first create the object, I want to have all these things initialized also. So I can call the method initialize from inside the constructor. But if I put all of these things inside the constructor, then it doesn't have that flexibility anymore. A worst way to do it is to copy and paste these 3 lines and paste it into the constructor. From the standpoint of making your software more maintainable, that is really a bad option. Copying and pasting, for the most part, is not a good idea. Does everybody understand why copy and paste is generally not a good idea in programming? Okay, very good. I try to emphasize that in my cisp363 class as well. Whenever you use copy and paste, you really have to ask yourself, do I have to do it this way? All right. So all these warnings should go away at some point. And they're not going away because I only initialize, but I don't make use of these numbers. Okay? Right. The other thing that we have to say is, okay, we have a method corresponding to the trigger of the user picking one of those 3, choices. But how would the model know which was actually chosen? Is it rock or paper or scissors? It has no parameters. Okay? Remember the alternative? The alternative is not to have one single user choose method to represent a trigger, but instead we split it into 3. User chooses rock, user chooses paper, user chooses scissors. But that is going to trigger quite a bit of copy and paste code. So that's not exactly a good idea. But if I don't use it that way, then I need a parameter here, because I need a parameter to say, okay, we'll let the user specify, or we'll let the external thing to choose, okay, what was the actual choice. In other words, we're parameterizing user choose as a method. So this time I'm smart, because I go back to the interface first and change the interface first. So when I change the interface, I would just add a choice here and say when we trigger this, when we have this trigger, user chooses something, we will also indicate what the user has chosen as one of those 3. Okay? Now at this point, because it's just an integer, you can internally keep track of this, and you say, well, since it's usually rock, paper, scissors, 0 represents rock, 1 represents paper, and 2 represents scissors. You can always do it that way. Just keep track of all the numbers and enumeration in your head.
I was about to say, does Java support like VB enumeration? Just give it a name and it automatically associates the value.
I think so. Like an enum. I think Java supports enum too, but I will double check. Yep, has its own enum type. So you have enum something, and then you give it basically the choices.
Okay.
Yep. You can always do it, without using an enum type. You can always use initialized integers, but make them static. In that case, it would be.
Becomes a little bit messy.
It is a little bit messy, but then you can also define bit fields because they're no longer sequential numbers. Using this way, you can never really know. It doesn't guarantee that it will start with a particular value. It doesn't.
I think it's like Sunday equals 0 or Monday equals 1.
I think you can also choose the starting number too. You can basically say Sunday equals something to force it to be of a particular value.
I think it works the same way as VB, where you just say the starting point, then it continues on until you say it continues on another value.
I think this one may support actually making the initialization for each one, and then here we have. Oh, you can associate a pair with a particular enum type too. That's kind of cool. All right. Well, now that we have the enum type, where are we going to put the enum definition?
In the interface.
Do we put it in the interface or do we put it into the model class? Now, think about it. Well, are you sure about that? Because the whole idea of the interface is to do what? Is to shield you from the actual class. So if you put this into the class, that means the view object will also need to know the model that it's using in order to make use of this. Now there are several ways to approach this. You can also make a new class, okay, for the sole purpose of defining these constants that is applicable to the entire game. In other words, it's not associated with the view, it's not associated with your adapters, it's not associated with your model, it is just something that is external to the entire thing. Which makes sense, okay? Or not? It makes sense because the view has to know it. Okay, when you click, the rock button, it has to know which constant to send along with the user choose method. And to add, just an enumeration, there are several ways to do it because in Eclipse, in the Java, framework, there's a way to do it without using anything else, because you can go to resources and just say, I want to add a new number. Okay, I just want to add a new value, and do it that way. You can also just use whatever Java has to offer to define that. One way we can do it is to define a class, because I do not think you can define
enum right there.
You're defining, well, in this case, you're defining an enum that is standalone by itself, which is okay. I mean, this is not. We don't have to contain it, because we are already inside the package, so we don't need any further containment, unless it's necessary. So we can say choices. And add it. Choose interfaces. Implemented interfaces selection. So it has to be affiliated with an interface. Choose to define a new enum type. So we have rock, paper, scissors. There you go. Now, because we have this new enum type available, we can actually go back to this part here, and instead of using an integer here, we can choose to use the enum type. Which is better than before, because now it forces whatever is going to pass to this parameter to be of the enum type. You have to use those particular names. You cannot just say 3, okay, which does not map to any particular choice.
Easier to debug as well.
Yep. But internally, it really is just an integer, which is great for efficiency. But as far as the Java engine is concerned, it can now attach additional code just to make sure that you are choosing the choices that is available to you. Now, doing it this way also has one extra advantage. If later on I want to extend it to include lizard and also Spock, this part doesn't need to change anymore. I can change the enum type. I have to change the enum type to also include lizard and Spock, but this part doesn't need to change anymore. If I use the other way, which means I have one method corresponding to each choice, user chooses rock, user chooses paper, and so on, I would have to change this one. And then I have to change the, I have to attach quite a bit of code to the actual model class also. This way is a lot cleaner because I don't have to deal with all that stuff. So do we have any questions at this point? Okay, we'll do one more thing. Okay, we're running out of time today, but I do want to kind of go through this process just to show you, how we kind of figure out what to do with this particular application. But first of all, have I even done anything at all with the screen, with the main activity itself? Nothing. Okay. But this is an app programming class. What about the app part of the app programming class? What about the user interface? All the fancy stuff that I want to put on the screen.
You can have all the fancy stuff you want, but without the code, you've got nothing.
That's one thing. That's one way to look at it. But until we, specify all the details of the model, we may not even know how many buttons or what kind of buttons we need on the screen. Okay, so that's why this seems to be reversed, because we are starting with all the back-end logic that has nothing to do with the user interface. But it actually makes sense, because if we start with the user interface first, then we think about the logic, and then we can basically at some point we can say, well, we need one more button to do this, because we didn't quite think through how the screen is going to interact with the business logic. So it actually makes more sense to start with the business logic first, and then we go back and say, okay, now how do we design the user interface so that we provide points to trigger all of these actions here. Because you know what? At some point, maybe you don't even want to do a button for everything like that. Maybe you want it to so that if you flick your phone, I'm gonna use my own phone as a prop here. Oh, right one, right here. Because you might want to play the game. If you flick your phone like this, it's rock. If you flick it like this, it's paper. And then if you jerk it like this, it is scissors. Okay. In other words, you can play your game without using the screen at all. You're just using the accelerometer. Okay. And at this point, do I care? Nope, not at all. You can also have your game played remotely. In other words, everything that we have done up to this point is running on a server somewhere else, running in Oracle Java. Isn't that possible? Everything that we have defined up to here does not say a single thing about how the trigger is coming in. It can be on the app itself, can be on the device itself, can also be coming in through a network connection. Am I getting that point across? It is it gives me a lot of flexibility at this point. Okay. So I'm just going to specify the logic of user chooses, because this one does have logic involved. And anytime I have logic involved, it does not belong in the interface. The interface is really just here to expose, okay, what does it have to do in order to qualify as a model object or as a model class? So in this case, it's complaining about what are you complaining about? Let's implement the okay, we just add unimplemented methods.
Since you changed it from integer to
enum. So we have choices. It's a single choice. And since I added a new one, I would have to remember not to choose that option and just modify the one that I already have. All right, that's cool. Okay, so now we have some logic to do here, because if I refer back to the state diagram, which is my element here, the guard condition needs to be specified somewhere, and now is a good time to specify the guard conditions. The guard condition is, does user win and does user lose? So now I have to keep track of two things, okay? Two other things that I have not implemented yet is what is the system itself choosing, what is the app choosing, and also how do I pass the information to the subroutine or the method, does user win and does user lose, in order to make that determination. So now you have to decide how are you going to, quote unquote, make a choice. Okay, how is the app going to make a choice? If you want to cheat, you can make a choice now. After the end user made the choice, then you can say, okay, in order to win, I'm going to make this choice here. Okay, but if you want to make the game fair, because somebody just wants to play it to kill time and not necessarily trying to get irritated by your app, okay. I wonder if anyone has written an app called irritation, just so that people can practice holding their irritation level low as an exercise. That would be kind of an interesting app. It's like I'm trying my best to irritate you and you're not getting irritated. Good job.
That's like that one show, Boiling Point. I don't know if it's on anymore. They used to have a timer up on the screen, and you'd use something really irritating to people that were unsuspecting of what was going on. And if they reached a certain limit, then they got a prize or something. It was like a hitting the irritation camera thing.
It also reminds me of Mythbusters. There was one episode, they were trying to figure out whether a irritated person, when he or she is driving, it would use more gas. So the team came up with all these different ideas to irritate Jamie and Adam and Jamie, to try to get them really, really agitated, and see whether they would use up more gas when they're irritated. It was funny. But making an app to do that, you know what, that can go viral.
Just play ads,
So here's
right?
your $1 million, chance, to write, an irritation, app, just for the purpose of irritating the end user. That would just have one single use case, right? What would be the name of that one use case?
Irritation.
To irritate. Yep.
But if they know they're trying to be irritated, you think that they should be able to suppress it.
Yeah.
Well, if it's coming from an app, most people don't get truly irritated because they know it's just a program doing it, right?
Maybe
you
you
can
should
link it to the bank account and like deduct money and add it.
Now just put in the description an app to install on your phone for someone else, like a friend.
I think within 30 seconds I upload this, class, recording, somebody's gonna make quite a bit of money by the time next time we meet on Wednesday. There'll be another Flappy Bird story. Make the app, make it go viral, and then pull it off from the Play Store.
Why do you think he did that? Why do you think he did that, for cultural
He
reasons,
explained
or
that,
what?
right? I mean, he explained that he did well. First of all, he's wasted too much time on his own game. I think that was one reason. And then the second one was he got all these requests for features, and he didn't want to deal with it. I think if you read about
Was
it,
he making $50K a day on the Google AdSense clicks?
I cannot remember. He was making quite a bit of money.
You probably could use that money and hire somebody to deal with it.
Yeah.
You just maintain the thing and just ignore all requests for update or for new features.
Yep. Okay, so what I'll do is I'm going to implement my own method here to make a choice. In other words, the app is going to make a choice using this subroutine. So that means I also need another private member here. App's choice is a member. And we don't use integers anymore, I keep forgetting, because it is now of the enum type choices. And the private method is, make app makes choice is going to implement that. Okay, so here we can say, apps choice equals to something. If you want the game to be kind of fair and actually kind of be, just probabilistic, you can just use the random feature. And I did not look up how to use the random feature in Java before. That's easy. Java random number.
How would it work with enum?
I believe it will work because as long as enum is going from 0 to whatever number that is the highest, you can always, okay, I'll show you exactly how to do that. I'll generate a number, okay, so math random is a random number generator. It is going to give you a ratio. Yep, so all of the solutions utilize this particular method. Okay, that's fine. Easy enough. All right, so what we want to do is to do something like this, because you don't want this subroutine to always have to go back to check the enum definition to find out what is the last available choice. Because if later on I add lizard and Spock, I don't have to go back to here and say, okay, now Spock is the last choice. So what I'm going to do is to make one definition inside the enum definition to deal with it. So I go to choices here, and I just say last choice, or something to the effect. Okay. In other words, when I make new choices, I always have to insert it right before last choice. So this number is always going to represent the last number available. Now the other thing I can also do is to have a first one. So this way, everything is going to be sequential within the first choice and the last choice. I don't really care, or I don't need to know where it's actually starting. It can be starting at 100. Well, doesn't matter because I can make my random number generator to take that into account, to take that into consideration. Okay.
Do you pull the choices to see the number of available options?
Say again?
Could you do? Is there like a method to look at the number of?
I think there's a way to do it. Let me go back to RPS model here. because you can go to choices and then use a dot here, and it will give you value of rock, paper, scissors. It doesn't give you the last value. It doesn't give you just the last value. So in this case, if I use, well, it does give you, yeah, you can use the other one. Okay, let me just do it again. It gives you a way to return the entire array. So
Then give the
values,
array method.
and then you can check the size of the array to know how many numbers are actually defined, and then you can work with that too. I mean, if you want to. But that usually may not be the best way to do it, because this method may have overhead, may not have overhead. It depends on the implementation of how they implement enum types. Yep.
This is off topic, but I've always been curious, how does a random work, like at a lower level? Like what's it doing to get a random number?
That's a good question. It depends. There are multiple ways to do it. The simplest way to do random number generation is they use a seed that has something to do with let's say your real-time clock, or something that is not predictable. So they would use that seed, and then the way they get to the next random number is to multiply the last number by a really big prime number, and then do a mod of that, use another prime number to use the modulo operator on that product, and then whatever is coming out of that number, they will do a truncation to truncate to whatever number of precision you need to use. So that's one kind of common way to do it, because it's relatively quick, but it's not entirely random, because if you use this method, at some point those numbers will recycle. Okay, it will just repeat a big, huge cycle. So what you asked is a really good question, because in certain applications, having truly random numbers is important, especially for encryption purposes. Because if people have a way to predict what the next number is going to be, some encryption mechanisms just don't work anymore, because now people can break your encryption scheme fairly easily.
I know in VB it'll continuously return the number of results each time you call next,
Right.
unless you seed it with your clock time.
Yep. So they give you a choice whether you want to seed it with a random factor or not, because for debugging purposes, it's helpful to have the same sequence of numbers, so that you can say, oh, okay, it always crashes on the 5th attempt. But if you have truly random numbers, then it may not happen again for the next 5 years. That makes debugging that application kind of difficult.
Why would it happen again in the next 5 years?
Because it may not give you the same sequence again. Because the way your program crashes may have to do with the sequence of numbers coming out of the random number generator. So if you start with a random number generator that is truly random to begin with, you may not get back to the same sequence of operating your program the same way. It's not deterministic. On the other hand, if your random numbers are just picking things out of a particular sequence and it's deterministic, then at least if your program is crashing during test, you can reproduce exactly the same scenario so that you can verify that bug is now fixed. And you had a question earlier? Oh, same question? Okay. Yeah, to really do random number generation correctly, okay, let's look it up. Random number generator. You can see that there's a surface just to do that. Because the only way to really get a real random number, they have to use a radioactive isotope of some kind, and then they use the timing between the emission of electron or whatever particle is emitting, as the actual random factor.
I know newer Intel chips have a random number generator within the CPU itself that uses like the hash or whatever random data that's in the buffer or hash stack.
I think some of them try to use noise on clocks.
Right, you can use the noise because anything that's thermal is going to have noise. I mean, it's just the nature of entropy. And noise in most cases is a bad thing, but in the case of a random generator, as long as the noise itself is not predictable, it is actually a good thing. So if you look up, just random number generator, you will see, a lot of references in terms of, what is truly a, good random number generator. Just getting back to here, we can say, choices dot last choice, and we'll make it multiply with math dot random. Okay. Then returns a pseudo-random double n, where n is greater than or equal to 0 and less than 1. It reuses a single instance of random. This method is thread safe. All right. And you can see that it refers to this number as a pseudo-random number, which means it is not truly random. It is only appearing to be random. Okay. Are there any questions about this description here? The description that it is a pseudo-random number means it is not truly random. Okay. Just kind of think about this, okay? If you can crack the random number generator, let's say used by a online casino.
The lottery.
Or, lottery is physical,
Yeah,
right? They actually use, those balls, But if you go to an online casino and they use a random number generator to deal the cards and whatnot, if it is pseudo-random and you figure out the pattern, then you can actually change the odds of you winning, because now you have a way to at least improve the chances of predicting the next card, even with other players involved.
You wouldn't know the pattern unless you know what it's seeded by, right?
You will have to observe the sequence many times for a long period of time, but you can establish that sequence at some point. It can be done by the process of elimination. In other words, you can say, okay, these numbers are the possible seeds, and this is the possible random number, the mod operators. And then you can just use the observable sequence to rule out possibility and say, okay, this is not the case, this is not the case, this is not the case. And once you have observed enough of that sequence, you can then narrow down to just a few choices. Even if you can narrow it down to maybe a tenth of the possible choices, you're still winning, because now you can say, well, I know it's one of these possible choices here. And that still improves your odds of getting the right number the next time. It's kind of like a web 128-bit web wire equivalent protection in a good older Wi-Fi routers. Does anyone know what I'm talking about? In older Wi-Fi routers, instead of using WPA2 as an encryption standard, they use WEP, WEP, which is a wired equivalence protection. Okay, and they only go up to 128-bit encryption, which is nothing. Okay, by today's standard, it is basically equivalent to nothing. Okay, they might as well name it NEP for naked equivalent protection, because there's none. Okay, and the way people crack the encryption is they listen to your traffic, and the more traffic, the better. But basically, the number is, if you use a normal amount of traffic, within a week, at the most, someone can crack your 128-bit encryption.
No,
it just takes a week.
Collecting, was it IVSs?
It collects
IVSs or whatever the encrypt, or I know you need like 20,000 of them or something like that for a
right.
successful
Not
crack.
a whole lot, but it's not a whole lot. Because they know certain types of packets must be sent in a certain way, so they can basically say, okay, I know these packets must have this content, but I can only see the encrypted form of those packets. So now they can say, okay, is it this key, is it this key, is it this key, is it this key? Now, granted, 128 bits gives you 2 to the power of 128 possible combinations, but the speed you can rule out the combinations is also very rapid. So they can narrow down to the actual key relatively quickly just by observing the traffic. let's get back to this one here. And it's complaining because this operator is undefined for the type. Okay. And I cast it. Type mismatch cannot convert from double to twices. Fine. Cast it one more time. Cannot cast from twices to int. Ordinal. There we go. And there's one more thing. The method twice double is undefined for the type RPS model. So there's no way to cast it. Cannot cast from double to twices. Okay, we can do it this way. Put an open bracket here and a close bracket here. Type mismatch cannot convert from double to int. Just matching the parentheses here. This open paren has a close here. So I need one extra pair. Goes all the way to the end. There we go. As I said, programming sometimes is not linear. But you can basically see how you can program when you have really a lot of help from the tool itself, because otherwise you'll have to kind of look it up and figure out what to do.
End up doing a bunch of research, just find out, nope, can't do it.
Or you can just send a message to a Stack Overflow and then go back and do something else. I'm gonna finish my game, and by the time you finish your game, you go back to Stack Overflow. Hey, guess what? The answer is already there. I wonder if anyone has used Stack Overflow in a live exam, in an online exam. I know some campuses of this district has classes where they teach high-level programming classes like 400, 401, and whatnot, and they used to have online final exams, which means
That ended quickly, I'm sure. So that ended quickly, I'm sure.
Is what?
So that ended quickly, I'm sure.
I'm not so sure. Last time I checked, there are still classes where you can get an A with just all the homework assignments without a face-to-face exam. All right, so I think I'm going to stop here, because we are well into the lab time. But this gives you an idea of how to proceed with your homework assignment with the H2O model. You basically have to start with the state diagram itself, which is already provided in that case, and then you have to define the model interface type, and then go back and work on the model itself. And at this point, with this particular program, I have not even started with the other really the useful stuff, because the only part I have done here is to say, okay, now we have a method called app makes choice, or makes a choice, to make a choice. But I have not even indicated when I'm going to trigger this particular method. There's nowhere that I'm calling this method at this point. Okay, so I'm going to work on this next time. It has to do with you can either do it in user truths, okay, which makes sense, or you can do it in some other place. But I think the best way to call this particular method is to do it here and just say app makes choice over here. Then by the time you also have the user's own choices, then you can make a comparison and determine which transitions can actually take place. Okay. So I'll go ahead and stop the recording unless there are questions related to what we have been talking about. Are there any questions? Is this helpful? Going through another iteration of examples and kind of explain why we do things in a certain way. Okay. Cool. Yeah, I think this is really a sharp contrast to what we did in cisp362, where everything is attached to just the event handlers, right? All the logic, we just throw everything to the event handler. Whereas in this case, we put all the logic to the quote-unquote backend, and use multiple types of encapsulation mechanism and abstraction mechanism to remove the view, which is the user interaction part, as far away from the actual business logic as possible, so that in between we can have any type of flexibility that we need for the application to to grow and continue to evolve. All right, any questions?
This is in regards to the assignment.
Yeah.
When do you want that in?
I do not have a certain date specified yet, because as we go through this, you might want to parallel what I talk about in class with the homework assignment. So that way, you can basically apply, what I demonstrate in class, but use that knowledge to apply to your own homework assignment. And that's my hope, is you guys would do that, just kind of shadow what I do with this example, so that way, you can kind of understand the concept and know exactly mechanically how to do that as well. Okay, that's a good question. Any other questions? Okay, if there are no other questions, I'm going to stop the recording, and if you guys work on the homework assignment here, I can come and take a look and answer any